Okay, so we're going to have to simplify this circuit into a circuit with a battery and a single resistor in order to get at what's going on inside resistor R8. So what's our first step? Well, you can't combine R3 and R8. They're not in series because they're not connected by a simple wire. R6 and R2 kind of look like they're in parallel, but if you look more closely you can see that they are connected by a single simple wire. So they're actually in series. So R26 is equal to R2 plus R6, which is 8 ohms. So let me redraw this circuit with R3 here, R8 here, and then R26 over here. Okay, now R26 and R8, they have the same voltage drop across them. So I can combine those two into R268. So that's 1 over 8 plus 1 over 8, which is 1 over 4. So R268 is 4 ohms. And now R268 is just a single resistor, so I can redraw this circuit again, like this, with R3 and R268. And then I can redraw this as R total. Those are in series, so that's 7 ohms. Alright, since I know R total, I know that delta V total is 24 volts, and therefore I total is 24 over 7, which is 3.43 amps. Okay, so I know that I want to get at R8 here, so let me start with R268. Okay, so since I total is 3.43 amps, I know that the current passing through that resistor is also 3.43 amps because they're in series. That means the voltage drop is IR, which is 13.7 volts. Okay, now let's consider what's happening with R8 and R26. I know the voltage drop from here to here is now 13.7 volts, right? So that means that the voltage drop, so delta V 268 is 13.7 volts, therefore the voltage drop across resistor 8 is 13.7 volts. And the power dissipated by resistor 8 can now be written as delta V8 squared over R8 squared. So that's 13.7 squared divided by 8, which is 24 watts. Okay, so we're done with that part of it. Now for part B, if the resistor R3 is replaced by a plain wire, so we remove this resistor. Well, that if R3 is 0, then the total resistance is reduced. Actually, the total resistance is reduced to 4 ohms, right? Because R3 is now 0, but R268 is still there. So that means that the total current is now 6 amps, which means the current passing through resistor 268 is now 6 amps, and the voltage drop across that is now, well, it's 24 volts. It's the whole thing, right? And so that means the voltage drop across resistor 8 is now 24 volts, and the power dissipated by resistor 8 is increased as a result. If you want to calculate it out, it'd be 24 squared over 8, which is 72 watts.